really nice to see you guys again.
Okay.
I'm looking forward to it.
Okay, so can I start? Huh?
Yes.
So, okay, hi everyone. My name is Tanittha. I'm a PhD student from Robotics Research Lab at the TU Kaiserslautern, Germany. And my paper is about adaptive perception for top view worker detection from using the crane camera. So there are high numbers of the accident from the crane. So the worker can be hit by the crane parts because of the operator cannot see what's happening surround the crane, or you can call struck by load accident. So in the previous work in ISARC, we provided semantic visual information by detecting the worker using data-driven approach and visualize to the operators. And we chose the existing load view zoom camera, which is already mounted at the boom ends as the image sensors. So, however, there are some sort of problems, especially from the deep learning method. So first, the deep learning detector struggles with the high scale invariance. Like in this case, the target size is the worker, can be dynamically changed by either adjusting the zoom level and of the camera or the boom movement, and the target size can be smaller than like 30 by 30 pixels, or it can be more than 100 by 100 pixel size, as you can see from here. And the second is if we want to solve the wide range scales by either changing network configuration and then you do some image pre-processing and then retrain the data, retrain the network. It also required high amount of data, and then it will take a lot of time to fine tune itself of the network. And the last point is in the previous study regarding the zoom control, although the studies exploit the zoom control to improve the quality of the recognition, and there are not that many evidences show the analysis of the zoom control, but just demonstrate the zoom constraint. For example, like giving the scenarios, the zooming is performed until the certain event, like zoom until 30 pixels. But in fact, the analysis of the zoom control is necessary because without proper control, the zooming can be oscillated. Yeah. So therefore, in this work, we introduce an automatic zoom control approach to avoid the further data gathering and extensive retraining. And the zoom adaptability method of the load view crane camera is able to support the deep learning algorithm, and specifically in the high scale variant problem. So we want to use the zoom mechanism to improve the quality of the detector itself by maintaining the overall size of the object and the area of the all objects in the certain area, which can be parameterized. So these two will be the main criteria of our zoom control. So the finite state machine is employed for our control strategy to adapt the zoom level. So to cope not only with the inconsistent detection, but also abrupt camera movement during the lifting operation. And our finite state machine is based on 3 scenarios: target loss, target area preservation, and target size preservation. And we will discuss about this later on. So the sketch here illustrates 2 scenarios of the proposed finite state machine. So the target size preservation on the left and target area preservation on the right. So the visualize of the target size constraint is shown as the translucent box. So the green colors mean all target embodying box the size are in range, while the yellow and red means they are out of the range. So yellow is too low and red means too high. For instance, here the green translucent show that it satisfies the constraint of the overall average of the target size. And as we can see here, the right figures, and it's visualized the overall target area constraint shows as the inner and outer border. And the color map also same, like red green, yellow also define the same risk level, let's say. And as we can see here, it depicts the violated case of the both side in size and the region. So here, the region here, this guy going out of the border, so it's become this border becomes red. And next is to make sure our zoom control works correctly. We verify the zoom logic controller by using APU tag as a reference target. So such the fiduciary marker give us the consistent and reliable input, unlike getting directly from the object detector itself. So here the target size that we use of the tag is 16 by 16 centimeters. And the test was set up on the hallway, and both of the tag and the camera were placed on the same ground plane. And from the videos here, it starts to search for any object because it cannot see any object. And once it's found, it starts to adjust the zoom until the diagonal pixel reach to the desired parameters that we set. In this case is 60 pixel or plus or minus 10 offset. We can set the offset too. And once it's reached the desired target size, it's changed. It's also, this is by testing, we change the target size parameters to be bigger. And then the zoom start to come again. But here currently that you see, the tag was moved, and then the zoom camera tried to adjust the tag. And now the target lost in this case, so it tried to search for the target again. In this case, and here when it start to go, it's searching for the tag. And then once it's found, now the size is not reached to the target desired size, and once it's reached to the desired, it becomes green. So after the zoom verification is done, we apply our zoom control to the actual top view worker detection from the crane camera. And on the left here is the result of the raw detection, by the right, also similar to the APU tag that I showed before, visualize the zoom control of the person. So this is the snapshot result. The first plot is the zoom level. As you can see that there's no oscillation despite the noisy sensor input here. Here is the size. This is the bounding box size of the overall target, and the zoom just adjusts based on the parameter that we set. So in this work, we investigate the zoom adaptability of the crane camera to support the worker detection by maintaining the size and keeping the target in the defined area. The detector is able to detect a small size object with the smooth continuous zoom control without additional training. And on the other hand, we may lose some overview information when we zoom in. However, we can focus only specific area. It can be set as the safety area that we want. And in the future, we want to control based on the errors or the size difference. For instance, like the greater the error is and the faster the zoom should be. And similarly, the choice of the detector should be considered. If we choose the detector which has very low frame rate, the zoom control will respond slow also. Then it will result the detector to miss the target later on. So that's all my content of my paper.